Okay, so let's do some physics collision detection here. Probably one of the most important things you'll learn in any game development series. How to detect when one thing runs into another thing, right? It's pretty essential. So here is the just starting scene file. I've called it main scene. There's no dummy node or anything. Like there was in lesson 1, but this project overall, what we're starting with is pretty similar to lesson 1. I'll just go through it all in the next like 2 minutes here. So we've just got box, capital B, box. Okay, this is the width, height, and length of it. I've got a light somewhere floating around in here, so it looks a little bit prettier. And then let's go over here to the main view controller. You can see that I've declared a box node out here in case we do want to use that in some other functions. And then here we go. We load up the main scene. I've put this function in here called setup scene, so we can just basically anything that we need to kind of associate with the declared variable, like our box. We'll do in here. This is pretty much identical though to what we had in lesson 1. So we basically just enumerate through all the children in the scene. We find the one named box. We make that node, right? Node.name. Node equal to this box. I've changed how we set the geometry a little bit from lesson 1, but I did leave that code in there if you wanted to use it. It seems to be a little bit more exact than this right here, which is a bit simpler. But basically, body is going to equal the physics body shape of the node itself, of the box. So we just say box.physics body is going to equal body. I've set the restitution to 1, so it's a little bouncy, and then I've just repositioned the box a little bit so it's further away from us, the user, and a little bit lower. So lower on the Y, a little further away. And then we've got a tap gesture recognizer, again, just like we had in lesson 1. And all we're doing is, this is the same exact code that we had in lesson 1 as well. So we're just throwing the ball out there, and we do that every time we tap, right? So here's the actual function that gets called when we tap, and then we just go over here and add ball, and then add ball, right? Okay, in terms of the configuration, I've made it so that we can see the feature points, the physics shapes, the world origin, and I'm sure down the road we'll want to do some horizontal plane detection. So that's it. That's what we're getting set up with here, and now we're going to add in the code to detect physics collisions. So first thing we want to do is we want to extend the what this class is capable of, basically. So we put in here SCN physics contact. Here we go. We're close. Oops, didn't get it all the way. Physics contact delegate. Well, let's just type it out. Physics contact. There it is. Delegate. Hey, one problem I had when I was initially setting this up, I accidentally put in there SK physics contact delegate. So just because you see physics contact delegate, be sure you got the right one. Otherwise, obviously, you're going to have some problems. Okay, so then after we associate this scene with our scene view.scene, what we're going to do is write down here scene view.scene.physics world.contact delegate equals self, which just basically means that this class is going to be the one that handles, seeing if one thing ran into another one, right? And actually we can add in, even right now, quickie little function, just type in func physics world. You'll see some stuff does start to show up over here, like this one, did begin contact. Okay, so go ahead and put that in for right now, and then we won't worry at the moment about basically inspecting the contacts. We'll just say contact happened. All right, so at least we know if this runs, we're in kind of good shape. Okay, so what we need to do is basically set some kind of identifiers for our box and our ball, okay? And we're going to do that up here at the top. We're going to write enum body type, and for anybody that's tuned into my SpriteKit lessons, this should look familiar. In those, for some reason, it always preferred UINT32 over here. Actually, we probably could have gotten away with int. I don't know. But here in SceneKit, it likes it to be int. And so basically what we're going to do is we're going to set up these different cases for identifiers, right? And we only really need 2, a box and a ball right now, but I'm going to go ahead and put a few more in here just to show you guys these should be in powers of 2. So 1, 2, 4, 8, and so on. So we'll put a little note, powers of 2. At least I believe here in the SceneKit world that's still the same. And then we're going to come down to, let's work with our box first. Oh, I skipped right over it. Somewhere over here. There it is. Okay. All right. So basically, the physics body initially needs this category bit mask. Okay, and we could just put in here a number, right? We could put in here 0, 1, 2, 4, and so on like that. But we're going to use that body type that we just set up. So we're just going to put in here body type dot box dot raw value. That way it's a little bit easier to kind of remember, what's what. Otherwise you're just constantly kind of being like, I can't remember, was the bit mask for the box so 1 and 0, whatever. So at least now it just says, hey, box. Okay. Then what we're going to start to do is define what you can collide with, right? So we're going to put in here collision bit mask, and we're going to make this equal to the ball. Oop. I skipped a line for no reason. Ball. Okay, that raw value. That means that the ball that we throw at this box is not just going to go right through it, which is by default is what happens anyway, right? But now we're really kind of specifically saying we want these two things to collide together, okay? And then on this next one, what we're going to do is write contact test bit mask. And again, this is going to equal dot ball dot raw value, which means we actually care about like listening in on the collision of these two things. Okay, so when they do run into each other, we'll get some feedback over here, and we can, basically go through and look at those contacts, who's who, and stuff like that. Okay, so if we really just didn't care about that, we don't need to set this at all. And if you wanted to set, in most cases you do, if you want to set the box to kind of listen in or collide with multiple things, what you do is you put this little pipe symbol over here, right, and then just put in like pyramid, right? Okay, so just as an example, I'll leave that in there. And did it just give me no, I don't think it did. Okay, so next thing we need to do is just kind of flip this around for the ball. So we'll go back over to here, and what we could do is we could say ball, and the body type for that is going to be ball for the category, and then let's just put box in there. You shouldn't actually have to do this because we've already set it for the box. But it's obviously not going to hurt either, okay? If both of them are kind of telling each other, hey, I care about you, you care about me, right? It should just be, one will work either way. Okay, so now, I guess, are we ready to test this out? Let me try. Okay, and sure enough, it does work. Here you can see I made it run into the box quite a few times. Contact happened each one. Let's watch it though, okay? And I've actually got two examples for you here. Let's see, that's the second one. Let's go over here to the first, where for some reason, even though it's winter, I'm pretending like I can still wear shorts. I wouldn't go outside though. Okay, so obviously the ball is bouncing off of the box. This is what I was talking about earlier, where that physics shape is just not perfectly around. I mean, and even on the ball too, it goes a little bit outside of it. So, wasn't like that in lesson 1. So maybe this is really the best way to do it. Anyway, all right. So what happens though if we comment out that line and this one, the collision bit mask, and that's what you're going to see in this second video over here. Okay, so you'll notice the ball just goes right through it, okay? Kind of see it halfway in, halfway out, right? Just their bodies are just completely ignoring each other, but you still get the contact happen print statement over here, okay? That's still occurring. So that's important, right? Which basically means that, you could use the box as sort of like an invisible goal area in some sense. You could take its set it to is hidden, if you wanted to just have it as just kind of this thing that you're using invisibly for triggering something else, right? But let's go ahead and keep them colliding with each other. All right, so we'll head back over to the the physics world function over here, where we did begin. Keep in mind, you can also just begin typing this type of the function physics did end. Okay, that's another option you've got over there. Did begin and did end are mostly what I would deal with SprayKit. But all right, so within here, let's take a look at what's actually happening. So you've got this contact option in here, right? So there's the parameter for that, and after it, so just type in contact. You can actually get things like the contact point. I mean, that's pretty crazy, right? Normally, I mean, most often I'd say I deal with just seeing what node A and node B are. So go ahead and just put in here node A, and then even though they give you a category bitmask right after that, turns out in SceneKit you need to put in here physics body dot category bitmask. Okay, so in this case we'll look at body type dot box dot raw value. And then we want to find out, because anytime two things collide, you've got two contacts. We want to see if body B is a ball. Now, this is kind of a really small example where we've really just got two types of things colliding with each other. So we don't really need to check this out, but if we had multiple things in here, multiple types of bodies, then obviously you're going to want to do that. So then you can just put in here print box, let's see, or I should say node bode. Node A is a box and node B is a ball. Okay. Then what you can do is just copy this entire thing, turn it into an else statement down here, right? And just switch around node B in this place and put node A over here. And then, of course, do the same thing over this way. And then you can see if the reverse was true, right? Because potentially you could have the box and the ball contact each other, and if you only had this first statement up here, this part might not fire because it could just happen to be that node B is the box, right? So you just keep in mind, you're always going to have to do that, right? Unless it's two things of the same type. So for example, what we could do is we could come down here, and you guys might have noticed this, if the balls weren't actually colliding with each other. It was kind of hard to tell because things move really quick. But so when we set these up, let's also make sure that the balls can collide with each other and that we're going to get some physics feedback on that. So put ball in there as well. And then you can come up here and let's just put ball in here, right? And then in this case, you don't need two versions of this because both node A and node B are going to be balls. So you can just say two balls collided. Nobody laugh. Okay, so I guess I could go ahead and run this. In fact, I'll just do it right now. Oh, my phone's locked. I don't think you really need to see what's happening, but you can read what is happening here. I probably should have gotten rid of the contact happen statement. But okay, so I'm just going to kind of, crazily keep, yeah, there you go. I saw it at least once happen. Two of the balls collided. Okay, so I think probably what you would notice is that, let's see, I'm just going to paste that in there. Now I'm going to try the reverse. What I'm getting at is I don't think, at least in my testing from earlier, yeah, it is kind of consistent. So you can see that in no cases was node B ever the box, but you really cannot rely on that being the case. Okay. And certainly when you have 10 boxes out there, some of the time, it's going to be the reverse. Okay, so that actually takes care of a lot of the physics stuff that I wanted to get into. Another thing that we kind of left out from before is, and you might have noticed this in your testing, we just keep dropping balls into this scene and we don't do anything about it. So let's put in here a function renderer, and then I think early on we talked about this. You've got all these different options in here. Hey, look at this. One of them is did simulate physics at time. But let's just go with update at time, and this is gonna kind of run, probably at 60 frames per second, right? And what I want to do in here is just see if one of the balls has gone so far out of view that we know, for practical purposes it's just gone, right? But it's still falling, which is obviously still going to cause the the code to treat it like it's there. So what we're going to do is we're going to enumerate through all the children in the scene, and if we find one named, remember we call these balls new ball, okay? So if you remember, there it is, new ball. And if we find one of those guys, well, I thought for sure I was going to nail this bit of code right away. Node.position.z is less than -10. I thought from that point, hey, look at that. This will be slam dunk. Not going to have to go on a Stack Overflow or anything like that. We'll just remove that guy. Print node removed. And it turns out that's actually not the line of code. You got to put in here node. And what's really interesting is if you print out what this is. Sorry, cliffhanger. Let me just put it in. Presentation is all you have to write. Presentation.position. But if you print out just this, okay, and you look at what the position is, it actually is not changing, right? How crazy is that? So if I run this real quick, you'll see what I'm talking about. So as soon as I put a ball down there, the print statement will start running. Okay, it's actually run now. All right. Oh, actually, I got to get rid of that. There we go. Okay. So look at that. This is staying the same. Now, keep in mind, it did eventually get removed because this if statement is set up correctly. So if we put in here, then presentation, right? Throw that back in. And at -10, we've been working with positioning things in those negative spaces. That's not too far down. Okay, so we'll see it print out for a little bit. There it is. And so it started off exactly what we would have thought, around -0, and then -0, and then around -10, it ends up getting removed. So and this is really interesting, if you go over here and you look at the quick help for this, a known object, let's see, as it currently appears on screen. So, yeah, this opens up a whole Pandora's box, I feel like, that we have to have this extra little property in here for finding out the actual positions of things. So, and look at this, but it says do not modify the properties of the presentation node. Okay, attempting to do so. It's like crossing the streams in Ghostbusters. Okay, but anyway, I'd say that's a big flashing footnote for us here, that we're going to have to consider this at times, that if we want to kind of get back those properties, we're going to have to put in there presentation.position.z, and then even doing some searching on Stack Overflow, I found there was times where people wrote that you should put in things like, now I can't say that you have to do this now or, whatever, but they had suggestions like this for when you were doing scene actions and stuff like that possibly you'd have to do something like this. But we don't have to do that right now. But again, yeah, we'll keep it in mind. So anyway, we've got, we've covered a lot of physics ground here, and I will give you guys the source files for the project as is. Just keep in mind we never did use a donut or a pyramid in here, but yeah. Okay. All right. So that's it for this one.